Hey, hi everyone, good evening and welcome to Cat Mojos. So here I am, Belvi Srinivas, bringing you the foundation module on numbers. I think we decided that in the past we'll do maybe about a couple of months, 1.5 to 2 months, we will be doing the foundation, followed by intermediate for about 2.5, 3 months, and then we will also do the advanced, followed by finally we will do the reinforcement. So that's how we have taken up the course structure. So I think yes, we did already about half a dozen odd numbers, half a dozen odd lectures on numbers. And here we are doing further, and this is one of the very important chapters, the remainders, because this sets the tone for most of our future learning on numbers, because it's one of the very important concept. Yes, remainder again is connected with the divisibility. From divisibility, it boils down to the remainders, and today I'm going to talk about one of the very important facets of these remainders. Of course, we will learn a couple of theorems, etc., but all that at the intermediate stage. But trust me, most of the questions, even in the exams, can be done by using this concept called as the preferred remainder concept. So that's what I'm going to discuss. It's a very important concept, so kindly pay attention as you try to learn alongside me. Yeah, yeah. Hi, Ashutosh. Good evening. Good evening, Ashutosh. Okay, here I am. So let me quickly introduce myself. So I've worked in the test prep. I've been working in the test prep industry since 2007. That's about 14 years now. Yeah, in the 14 years, I did work both on the management side of it and also on the training side of it. In the training side of it, I trained the students as well as the fellow faculty members in the areas of QA, TI, and LR. Yes, and you can look at this deck where kind of I put in my experience. That's briefly about me. Yes, you can also have, if you are also having the counseling needs, you can reach out to me. I'm a good counselor as well. I will certainly guide you on your preparation as to how do you get along, how do you go along. But before that, naturally, any guidance will come with the profile sharing. You might have to share your profile, you may have to let us know a little bit about it. Then we will kind of work together. So how do you reach out to me? Therefore, you reach out to me by using the Telegram channel, one of the Telegram channels. Yeah, not only I, you can also have some peer learning experience well on this particular Telegram channel, along with your concerns getting resolved either by me or the peers, all that. Right, that's briefly about me. That's briefly about how we can go about. A couple of announcements before we start. You might get some doubts as you start working together. So as you start working on the concept, so whatever be the doubts, be it in the area of QA, DI, LR, RC, so whatsoever be it, so you can always use that Ask a Doubt feature on the Unacademy app, and you can put up to 3 doubts at once, right? And it's a self-explanatory app. Just in case you find that on your dashboard you are not seeing this particular application, then probably you may have to reinstall or you may have to refresh your application. Probably that will help you to see this, because yes, you do get a handful of doubts. It's very important that your doubts are kind of getting resolved. Yeah, and just in case you have taken the CAT 21 and you are expecting some good results, good result, so you can enroll for this particular program. So where it is, so if you have done that subscription, so you will get 10 times of your subscription fee back. So this is only for the CAT 21 students. I know that most of you won't be here, those who are appearing for the CAT 21. Just in case if you are here, that's for you. Not only that, in case all let know, so you appeared for CAT 21, and if you are expecting about 80 percentile and above kind of score, in that case you can and in that case you get 30% scholarship on the subscription fee, only for 1 year program, right? 30% subscription, just in case you have taken the CAT and decided that you want to repeat CAT, only in that particular case. And second condition being you are expecting a percentile of more than 80. That's pretty much about the announcement. So here is, let me quickly do some quick recap as to what we kind of discussed in the previous lectures, right? So we said one of these properties, if I have a couple of numbers, number 1, number 2, number 3, if this is divided by certain divisor, so it leaves, so what is the remainder? We said that okay, in that case we can use the property of isolation. So I will call this as the isolation property, right? That is one of the properties which I already discussed as a part of the divisibility concept, right? So isolation is what you say that, hey, I don't have to add up those numbers. I will take the number 1, I will divide by the divisor, I will list the remainder. Plus, because there is a plus, you add that. You will take the second number, you divide by the divisor, you list the remainder. Similarly, you take your third number, you divide by the divisor, and you list the remainder. Technically, let's say that the remainder here is R1, the remainder here is R2, the remainder here is R3. You kind of add, subtract, whatever be the sign between them. This is called as the isolation. right? That's one of the properties we kind of discussed there. And secondly, second property that we said is if I get to know that when a number is divided by divisor leaves a remainder are given this piece of information, then we say that hey, I can derive a couple of things, right? When the number, same number, k times of the number is divided by the same divisor, the remainder should be k times of r. B, from here we said that when number raised to power k is divided by the divisor, it also leaves the remainder, which is r raised to power k. C, we also said that when k times of the number is divided by k times of the divisor, your remainder also would still become k times of r. Right, so these are the three other things that we kind of discussed. This is what we kind of put into perspective in one of the lectures. So why I'm talking about this, probably some element of this we are going to talk about today as well, right? Okay, now I introduced the word preferred remainder. What do we mean by preferred remainder? Trust me, in most of the exams, so leave aside maybe, yeah, even including CAT, etc., if you take a season of last 5 years or so, so half of the questions, more than 50% of the questions, right, more than 50% of the questions on remainders can be solved by just knowing the preferred remainder concept. Right, more or less by knowing the preferred remainder concept. Okay, if 50% is an exaggeration, you can say that okay, about 40% of the question, right, can be done by just this particular concept. Let's see what do we mean by that. And as you go along, this is a very important concept, because even at the higher level into the theorems, we make use of the concept that we are talking today. Let's take a look at this theorems later. So there are a couple of theorems as well. You may say that hey, we know remainder theorem, Fermat's theorem, Euler's theorem, Wilson's theorem. Surely, right, we will come into that when we do the intermediate part of our lecture. But for the time being, so it's very important that we are completely capitalized on the preferred remainder concept. What does it mean to us? Let me illustrate this using the examples itself, because that's a lot more easier. Right, let me take the example itself because it's a very simple topic. So I will straight away start with the example. Preferred remainders, let me just mention that what is our preferred remainder. Just remember, preferred remainder is 1 or minus 1. You may wonder, why 1? Why 1 is preferred? For a simple, 1 is preferred as a remainder, not as a divisor or the number, right? It's as a remainder. Why 1 is preferred is 1 raised to power anything is 1. That's a beautiful thing. Why minus 1 is preferred? Minus 1 is preferred. Minus 1 is preferred for a simple reason. Minus 1 is preferred. Yeah, minus 1 because of two reasons. Minus 1 raised to power even number, that is 2n, leads to 1, whereas minus 1 raised to power odd number, 2n minus 1, odd number, technically I'm saying power is odd, leads to minus 1. So good. So here I have a unique choice. Here I have two choices, right? So two choices. Therefore, it's very easier. So, however, this is not true when I say that, hey, why can't I call 2 as a preferred remainder? Think about it. If I say that 2 raised to power n, what is it? Don't know. 2 raised to power n, no idea. If 2 raised to power n depends on n. If it is 2 raised to power 1, then it is 2. If it is 2 raised to power 2, then it is 4. If it is 2 raised to power 3, then it is 8. If it is 2 raised to power 4, then it is 16. 2 raised to power 5, all right, then it is going to be 32, and so on. There is no answer to this. However, had I written this as 1 raised to power n, no problem. 1 raised to power 1 is 1, 1 raised to power 2 is 1. Put the same powers for 1, right? It becomes always static, it remains 1. Same thing with minus 1 also. Minus 1 raised to power n. So either I will get 1 or I will get minus 1, minus 1, 1, minus 1, 1. It oscillates only between this. That's precisely the reason we call these two as the preferred, because I don't have too much of variation there. One of them is pretty static. The other one swings between 1 and minus 1. I can't call 2 raised to power n or 3 raised to power n anything else as the preferred remainder, because the values are dynamic. They keep changing, right? Fair enough. So let's keep that in mind. So what I'm talking is 1 and minus 1 are preferred, but will it be that direct? How will the applications look like in some of the exams? Let's take a look at this, right? Let's take one of the examples. Find the remainder when 64 raised to power 81 is divided by 9. Very simple example I'm giving. Hey, take 164. Always start by ignoring the power. Don't bother too much about the power. Don't worry about the power. Look at the base of the number. This is the number. My number has base and a power, right? Don't worry about the power. Look at the base. When 64 is divided by 9, the remainder is 1. But we know already from one of the remainder properties, when the number is divided by divisor, if it leaves a remainder r, when the number is raised to power k divided by the same divisor, then the remainder will be r raised to power k. Precisely that is what I'm going to apply. But author is saying that, hey, I didn't ask about 64, I asked about 64 raised to power 81. Put that. Therefore, 64 raised to power 81 when divided by 9, the remainder should be 1 raised to power 81. Therefore, the remainder is going to be 1. Very simple. We just listed 3 or 4 properties. All we are going to do is we are just going to capitalize on those properties. Yeah, as we go along, the examples need not remain this simple. So I will increase the complexity and few other things, but yet foundation remains foundation. It has to be simple, right? But there is always there is a good to good. It's good to recall the foundation part of it, because we cannot fumble at the foundation stage itself, right? Yeah, okay. So let's move on to the second one. On this note, let's go on to the second one. Hey, what if the number looks something like this? 62 raised to power 81. Again, a preferred remainder. What I meant, hey, take a 62. When you divide by 9, you may say that, hey, the remainder from 62 divided by 9, you may say that the remainder can be 8. Remainder can be 8, because 62 when divided by 9, 54 is divisible 8. Or I can take the same 62. You may wonder from where you got this 62. Yeah, I said that my number is of the form a raised to power b. Always look at the base to start with. Ignore the powers to start with. Look at the base. Only base and the divisor are important. 62 by 9 I can call it as 8, or 62 by 9 I can also call the remainder as minus 1. Why? If I say that in 62 I went up to 54, then 62 minus 54 gives me 8. Or in this 62, if I say that is 9 sevens are 63, alright, if I go up to 63 and look back at 62, I am one short of becoming the multiple of 9. Now what I do here, I say that, okay, at this here we say that, okay, I ignore this, and I pay attention to this. Why? Because this fellow has become my preferred remainder. We capitalize on the preferred remainder. Minus 1 is the preferred remainder. Reason? Now with author says that I raise it to the power 81. Sure, I will raise this to the power 81. Therefore, minus 1 raised to power 81. Hey, what is minus 1 raised to power 81? Minus 1 raised to odd power becomes minus 1. But the point is, answer cannot be negative. Remainder means something which is left behind. Left behind cannot be negative, right? Yeah. So therefore, you say that how do I make it positive? Add the divisor. You look at this minus 1. You say that my negative remainder is minus 1. Positive remainder means add back the divisor. You add the divisor and you claim that your final remainder is nothing but 8, right? Good. So my point is what? When you look at the preferred remainder, sometimes you may get a positive remainder, sometimes you may get a negative remainder. Just in case you get a negative remainder as the answer, nothing to panic. Add the divisor back, you get the positive remainder. Pretty simple questions, pretty simple question. But the idea is the whole today that we are going to spend the next 30-40 minutes is what? The importance of preferred remainders, right? How do I look at the preferred remainders without really jumping into the theorems, etc. Right? Good. All right. I hope all right, it's making some sense here. Right? Making some sense here. Yeah, what is the remainder when 3 raised to power 52 is divided by 244? Suddenly it looks like, man, what you have done? All right, the divisor looks a little large. Yeah, surely. All right, now, so earlier divisors were small there. So now the dividers look, yeah, thanks Ashutosh, thanks for confirming. Yeah, so the remainder looks a little larger. What do we do? Nothing to worry. You may have to have some understanding of the base. We understand that a 3 raised to power 5 is nothing but, all right, 3 raised to power 5 is nothing but 243. It is important to know that. So therefore, sometimes we say that, hey, why don't you remember the powers of 2 up to 10? That is 2 power 2, 2 power 3. Like this, we say that 2 power 10, sometimes 2 power 11 or 2 power 12. It is good to remember this particular series still there, not keep calculating what is 2 power 10, etc., etc. Right? Similarly, we ask you to remember 3 power 1, 3 power 2, this particular series, at least up to 3 raised to power 6, which is 729. Kind of, all right? Now, till there it is kind of important, right? Therefore, we kind of pay attention to that. Fair enough. Now, let's take a look at this particular question. 3 raised to power 5, right? 3 raised to power 5 is 243. You may wonder why 243? Because I'm having a base of a divisor called 244. And we are having that idea of preferred remainders. I've already conditioned your mind that, hey, you will get a preferred remainder somewhere there, right? That's a conditioning of the mind. Fair enough. Sooner or later, you will get a preferred remainder. Therefore, you say, okay, 3 raised to power 5 when divided by 244, the remainder is minus 1. Fair enough, that is what you got. But author says that I am not interested in your power called 5. I am interested in a power called 52. Right? If it is 52, you would say that, okay, I will go up to 10. So which means I'm walking towards this 52. I walked up to 50. Then here also minus 1 raised to power 10. What you are trying to say? You are trying to say that 3 raised to power 50. So because this whole thing is 50, when divided by 244, the remainder is 1. Okay. Then we had this particular property there saying that k times, this was my number, k times means say what is that, 3 raised to power 2 extra, because I need to go up to 52. Therefore 3 raised to power 2, then multiply by both sides. Say which property I am using? When the number divided by divisor, if it leaves a remainder called r, k times of the number when divided by the same divisor leaves k times of r. That is what I precisely did. This was my number. When divided by 244, the remainder was 1. Then what did I do? I said that okay, if I multiply by 3 square times of the number, my remainder also becomes 3 square times of the remainder. Right? We are using just those simple properties we learned in one of those classes out here. So therefore my answer becomes 9 out here. Pretty simple one. So I just illustrated some of those properties that we did there. So use those properties and use the preferred remainders in more often than not. In most of the questions it kind of works. At least if you write, when you take CAT, ZAT, CMAT, etc., it's more about the preferred remainder concept. More often than not, it simply boils down to preferred remainder. No, I should understand that, do I see it in that fashion or not? Now, where is this preferred remainder start? All this is taught in a kind of high school, college stuff, right? Yeah. Okay, let's move on to the next one. Let's move on to the next one. Why don't you guys take about a few seconds to answer this? Just take 2 seconds. Yeah, all right. So what do you say? You take one base. Which base? Take the base here. 81 when divided by 13. Remainder is 3. Right, because I can go up to 78, right? 13 6 times 78, but you will say that 3. But you may wonder, so where is preferred remainder here, right? So where is the preferred remainder here? That may become a question there. Fair enough, you keep it there, no worries. 81 when divided by 13, the remainder is 1. First make it small, but 81 raised to power 81, then it will become 3 raised to power 81. Oh my goodness, now it has become large. 3 raised to power 81. Fair enough, no worries on that. 3 raised to power 81, is it greater than your divisor? Of course yes. If it is yes, then why don't you divide again? Because your remainder has to be less than 13. Your remainder cannot be equal to 13 or more than 13. Remainder has to be necessarily less than the divisor. So therefore you say that 3 raised to power 81, of course it is much larger. Therefore 3 raised to power 81 divided by 13, good enough. So now what you do a remodeling, repackaging. So now you know the powers of 3. Hey, when 3 power 3 is divided by 13, the remainder is 1. So now again you look at this proposition, right? But then I don't know what is 81. Start with the smaller powers. You say that 3 power 3 when divided by 13, the remainder is 1, because 27 when divided by 13, the remainder is nothing but 1. Okay, but you need to go walk up to 28. Walk up to 28 implies, walk up to 81 implies that, okay, model this. You say that, hey, this is raised to power 27, therefore 1 raised to power 27, and then the final remainder is nothing but 1. You really don't need too many theorems to start with, right? Let's be very clear. Like when we do that, we don't need too many theorems to start with. First, we need to build this quotient. And some questions with this simple quotient of preferred remainders may get complex. That is when we learn few theorems to resolve them. Otherwise, more often than not, preferred remainder is the beginning stage for most of the questions there. Fair enough. All right, therefore, you say that the answer is nothing but 1. I'm hoping that you are kind of getting hang of this, what I'm talking, right? I'm hoping you are getting kind of hang of this. We will go dive little deeper into this. We will go dive deeper into this. Before that, let me quickly allow me to do some quick announcements. On 5th of January, there are 2 batch launches. There are 2 batch launches on 5th of January. One of them is a weekday evening batch. The other one is for engineers specially. You may wonder, there are different batches which kind of start, right? So there are structured courses. The different batches start technically every week. At least a couple of batches start on Unacademy platform, for a simple reason that every batch has its own objective. You want to understand the objective. These 3 educators would have made a couple of minutes video. Each one of them would have made 3 to 5 minutes video to tell as to how they are looking at this particular batch, what kind of students they're expecting them to attend, etc. Right? Because it's technically for engineers, therefore they would have taken a level that if somebody is teaching a QA, they might have thought that we will start directly at the intermediate level by doing a quick recap of the foundation level. There will not be an emphasis on foundation the way I'm trying to emphasize on the foundation on this, right? Similarly, there might be another group on it which might have decided that, hey, this we will also focus on the people, those who kind of forgotten most of the foundations, and then when you go back there, probably the other batch may be doing QA, they may say that, hey, we focus on foundation and then we will lead up to intermediate. Likewise for the RCs, for the grammar. So you will find you may have to go through the educator video to quickly to understand what decision, how they want to take this batch, what is the batch the batch process is going to look like, in the sense the pedagogy is going to look like in that particular batch, and so on. Yeah, that's a structured course. Of course, the structured course you might have to buy a subscription. It comes with a subscription package. You have various subscriptions, so you have various kind of subscriptions, and for each kind of subscription there are different kind of different kind of subscription fees, and all these subscription fees, yes, of course you do get 10% discount whenever you use any of the educator code, right? Including my code, which is Belvi 100. You get 10% discount on this subscription fees, right? Yeah. But my preference has been, of course, along with the subscription, you get test free. It can be a full-length test, it can be a sectional test. You will get some learning documents free. So all that you get get it free. But my preference has always been iconic subscription. There are two types of subscription Unacademy offers. One of them is called as Plus, the other one is called as iconic. I prefer iconic subscription for a simple reason that in an iconic subscription you will be speaking to mentor in a one-to-one capacity. How many times you can speak? If you buy a 6-month subscription, you can speak up to 25 times. So who sets the agenda? You can set the agenda what you want to discuss. Or it can be discussion of your doubts, it can be discussion of your concepts, or it can be the discussion about how you should prepare, what should be your monthly calendar for Jan look like, the Feb look like, the March look like, once the mock test starts. So how you have to strategize for the marks based on your strengths and weaknesses. You can pick up the topic of discussion and start speaking about it. Yeah, technically 6 months have about 26 weeks. You will get to speak about 25 times, in the sense that every week you can kind of take a stock with your mentor. You can sit with your mentor and you can take stock of what is the progress, where it has been going. You can have those kind of brief discussion. Similarly, 12-month subscription, you will get 50 one-to-one discussions, right? Here you can avail up to 100 one-to-one discussion, technically one per week. The rationale is speak to your mentor at least one per week with the agenda that is there in your mind. What is bothering you? Speak about that and unleash and move forward. That's the whole idea about the iconic subscription. In addition to that, of course, all other things like structured course, material, this, that, all that you will get. In addition to that, you will get this one-to-one capacity of talking to the educator of your choice. Fair enough. On this as well, you get 10% discount. So whatever the subscription fee that you are kind of looking at, on this as well, you can avail 10% discount when you use the educator code, which is Belvi 100 in this case. Yeah, there is solid now offer closing today being the last day of this particular offer. So if you're planning to make a buying subscription, probably January, today is the last date, so you get 22% off, right? So I said that earlier, you get 10% discount. Use educator code, any of the educator code, to avail 22% off on the subscription fee of your choice, right? That's only for today. Coming back to the lecture, okay, that sets us in the perspective. So what I have to say about certain subscriptions plans that you have. Yeah, here we come back to the lecture. Let's take a look at this. Let's come back to the preferred remainder lecture. Yeah, what is the remainder when this is divided by 17? Again, very similar to one of the previous questions we did. You don't see the preferred remainder right in the beginning. 66 when divided by 7, you say that the remainder is 2, but you say that, hey, I'm not finding the preferred remainder. At times you need to be a little more patient. You may not see it in the first go, you will see it in the second go. Okay, raised to power 42, this also is raised to power 42, but the point is, does 17 divide, is 2 raised to power 42 greater than your divisor called 17? Of course, yes. Therefore your problem now turns out like 2 raised to power 42 divided by 17. Now how do you look at this? Now you say that from here you would say that 2 raised to power 4 when divided by 17, the remainder is -1. 2 raised to power 4 is 16. How do I go up to 42 from here? Therefore, you say that hey, 2 raised to power 4, when raised to power 10, it will become minus 1 raised to power 10. Technically, from here, you are trying to say that 2 raised to power 40, when divided by 17, the remainder is 1. But the point is, you are supposed to be reaching up to 42. You got to be reaching 42, and hence you say that I will multiply the number by 2 power 2. Thereby, you got to be multiplying the remainder also by 2 power 2, and hence your answer becomes 4. Technically, after some time, these kind of questions you can churn out in your mind itself. Yeah, but for the time being, get the concept very clear. All this kind of stuff you learned in the high school, of course, already now. So you may say that why we didn't do some part of this in the high school. But high school, when I say that, technically math Olympiads, those who have taken the math Olympiads, you might do that. So because even when the CAT says that 10th is the syllabus, etc., it is the Olympiad syllabus, right? Because they want the champions. I am Ahmedabad, naturally, Ahmedabad, Bangalore, whatever. They're looking for the champions. The CAT is done for them. It is not already now somebody who has done the high school at the elementary quantitative aptitude. No, they are not looking just at the elementary. They say that okay, you're putting some substantial efforts and you remember the concept which we are going to use in the case studies at the B schools, which is very, very important. You may say that, sir, what is the usefulness of all this quant? Oh man, your B school has so many functions. Your operation research, profit maximization function, or cost optimization functions. All these are nothing but pure math, right? There is a linearity, there is a logarithmic, there is exponential. If I don't understand this, how I'm going to work with those particular functions, how I'm going to work on the processes in the industry, it's not possible, right? Technically not possible. Therefore, if they expect that's a precise reason that you need to be good in quantitative aptitude to make some sense even while doing certain management case studies or learning some management subjects. There is no choice in the matter. Fair enough. All right, let's go further. Let's go further. Don't think that already all this they will do, why they are doing it. No, they're very, very clear. It is not that the B schools are mad to ask some quant questions. Of course not. There is a clear usefulness built around them. Therefore, they ask. Okay. Yeah. So let's take a look at this. What's the remainder when this is divided by 11? All right, when this fellow is divided by 11, you may probably take about 30 seconds to answer this particular question. It might make some better sense. Why don't you take quickly some 30 seconds to answer this? At least get started. Even if you don't close it, I'm fine. Get started. Yeah, you might have noticed. Second stage. All right, you'll get the preferred remainder in the second stage. 58 when divided by 11, the remainder is 3, right? Okay, but then 58 raised to power 75, therefore 3 raised to power 75. Is this greater than 11? Of course, yes. It is much, much greater than 11. So now how do I go about this particular one? Again, you have to do 3 power 1, 3 power 2, 3 power 3, all that stuff. Then you realize, okay, you need to go here 3 raised to power 73. You understand that, okay, 3 raised to power 5 when divided by 11, all right, which is nothing but 3. What is 3 raised to power 5? 243. When divided by 11, the remainder is 1. All right, 200, because 11 divides 242. All right, 3 raised to power 5 when divided by 11, the remainder is 1. 75 means what? 75 means I need to do this about 15 times. So therefore 1 raised to power 15, the remainder is nothing but 1. What I'm trying to say is, hey, the preferred remainder, sometimes you may get it at the stage 1. So stage 1, this was the output. But now then you say that you look at this stage 1 and then you regroup this 3 power 5, when divided by 11, the remainder becomes 1. You get this preferred remainder at the second stage and then regroup at the second stage, right? So I hope you are getting some hang of this. You're getting some hang of this. Try this very simple question. Try this quickly. Try this. Try this quickly. Try this. We're getting hang of this. Pace up, pace up, pace up a little bit. Yeah, all right. When 11 divided by 13, the remainder is minus 2. When 11 is divided by 13, the remainder is minus 2. Therefore, 11 raised to power 154, the remainder becomes minus 2 raised to power 154. What does it mean? It is as good as 2 raised to power 154. Why? Minus 2 raised to even power is nothing but 2 raised to power 2 raised to power 154. Okay, so therefore, is this number greater than my divisor called 13? Of course, yes. Therefore, what do you do? 2 raised to power 154. So, 2 raised to power 154 when divided by 13, what is the remainder? That's what I need to now figure it out. So, now you say that, hey, groups the powers of 2s such that when it is divided by 13, the remainder becomes, or how do I group it? You say that 2 raised to power 6 when divided by 13, the remainder is 1. 2 raised to power 6 when divided by 13, remainder is 1. What is 2 raised to power 6? 2 raised to power 6 is 64, right? Yeah, 64. Remainder is minus 1. Remainder becomes minus 1. Good. But the point is, you need to go up to 154. All right, let's go there. So if I were to go up to 154, 6 2 times 12, then you have 34, then 6 5 times 30. Right, yeah. So you went up to 150. From here, what is that you are trying to say? 2 raised to power 150 when divided by 13, the remainder is minus 1. The remainder is minus 1. Let's keep it as it is. Now what I am supposed to be doing to this? Now you say that you need to go up to 154, 4 more. All right. So if I were to do 4 more, you say that, okay, I multiply this side by 2 raised to power 4. I would multiply this side also by 2 raised to power 4. And hence you are trying to say that, okay, 2 raised to power 154 when divided by 13, the remainder is minus 6. Why minus 6? Because minus 1, and then you are trying to say that 2 raised to power 4 is 16, minus 16. Similarly, you do that, okay, I will, because negative remainder, add divisor. If I add divisor once, if you add divisor once, you will get minus 3. Not satisfied because it's still negative. Add the divisor once again. When you add the divisor once again, you get the remainder as 10. So final answer for this particular question is going to be 10. Find the remainder when 11 raised to power 154 is divided by 13. You say that it is nothing but 10. 10 would be the remainder for this particular question. Okay, first stage. In the stage 1, you may not see the preferred remainder, right? Yeah, that's what you say there. Output of the stage 1 looks like this. Output of the stage 1 looks like this. Then you take the stage 1 output and then you regroup it. That is 2 raised to power 6 when divided by 13, the remainder becomes minus 1. From there, you again make the regroups to reach this 154. While reaching that 154, we spoke about 2 or 3 minor concepts. Use those minor concepts which I recapped it in the beginning of the lecture. Use it. Otherwise, there is a lecture which I have done based on this as the remainders, or remainders as the remainders itself. Please go back to that particular lecture and try to understand these 3 or 4 concepts that I am talking about. Good. So that should put us to the perspective. Let's take a look at another one. Let's take a look at another one. Why don't you guys take about 20-30 seconds and push your thoughts a little bit. Push yourself, spend some time. Just 30 seconds, get it started, because I don't want to make your brain completely passive. Yeah, you might have got some idea by now. So, okay, let's take a look at this. Hey, when 110 is divided by 21, when 110 is divided by 21, the remainder is nothing but 5, right? Remainder is nothing but 5, because 105 can be cancelled. 105 goes off, the remainder is that. All right, but the author says that, man, I didn't ask 110 by 21. I asked 110 raised to power 220. Good. I will raise this to the power 220. Then 5 will also be raised to the power 220. Is 5 raised to power 220 greater than 21? Of course, yes. Therefore, you say that, okay, I take this now 5 raised to power 220. I'll divide this by 11. I divide this by 21 to figure out the remainder. Now again, so what comes to your mind? 5 cube. We know that when 5 cube is divided by 21, the remainder is nothing but minus 1. Yeah, what is 5 cube? 5 cube is nothing but 125. So what is 21 into 6? 21 into 6 is nothing but 126. Therefore, the remainder is minus 1. Good. With 3, I may have to go up to 220, right? I may have to go up to 220. All right, model this. Yeah, how many times you can go there? 3 7 times 21, then 3 times. So therefore, you say that you went up to 219, right? You went up to 219 raised to power 73. What you are trying to say from this particular story is 5 raised to power 219 when divided by 21, the remainder is minus 1. Good. But the author said that, hey, I want 2 raised to power 20, right? 2 raised to power 20 is what I am questioning. Good. So therefore you say that multiply this by 5 raised to power 1 because you need to go up to 220. So this side also you multiply by 5 raised to power 1. Therefore you are trying to say that 5 raised to power 220 when divided by 21, the remainder is minus 1. Good. But minus 1 I will not take it as a remainder. What do? Add the divisor. Minus 5 plus 21, and hence you say that the remainder is nothing but 16, which is my answer. Right, 16 is the answer for this particular question. I'm hoping that you are getting, I'm making some sense. You are getting this? Everybody getting this? You're getting this, what I'm trying to say? Yes. Very simple questions. Only one concept I'm telling, preferred remainder. Getting this? Yeah. Great. That's nice. That's nice. Thanks, Justice. Thank you. Yeah, let's take a look at this. Let's take a look at this one. Yeah, take about 15-30 seconds. Take about half a minute. Think about this. Yeah, okay. Guys, always keep a book and a pen. Doesn't matter whatever the lecture that you do, whether you are doing my lecture here or any lecture, always sit with a book and a pen and try to follow it for some time. All right, that is when you will start making some sense, right? So if you're following something, always use a pen and a book. Otherwise, you'll be simply wasting your time, and the time is very precious for us. No need to do repetitively the same stuff. So build it very structurally. It would definitely help. Okay, let's take a look at this. 315 when divided by 104, the remainder is 3, right? Because 104 3 times is 312. Remove 312, we get that. But author said that, hey, I want you to raise it to the power 315. Okay, so therefore 3 raised to power 315, that's a remainder. But is that remainder greater than the divisor? Of course, yes. Therefore you say that in the second stage, 3 raised to power 315 when divided by 104, what is the remainder? Again, I told you that, okay, so you may have to go through the powers of 3. If that is in your mind, it becomes a little easy for you to identify the things. Otherwise it may not make sense. Okay, therefore in this case you say 3 raised to power 6 when divided by 104, the remainder. All right, what is 3 raised to power 6? 3 raised to power 6 is 729. Okay, therefore what is 104 into 7, right? It will become 728. That is what I was talking about. The remainder becomes 1. But the point is, I need to go up to 315. Fair enough. So therefore you say that 3 raised to power 6 whole raised to power 52. You have gone up to 3, already nothing but 1 raised to power 52. What does this mean to us? 3 raised to power 312 when divided by 104, the remainder is 1. But what is author expecting us? He said that 3 raised to power 15 is what I am expecting. Good. Therefore you multiply this side by 3 raised to power 3 to go reach 315, and hence this side also you multiply by 3 raised to power 3, which is nothing but 3 raised to power 315 when divided by 104, the remainder is nothing but 27, which is the answer for this particular question. Point is, yes, they do ask us these kind of numbers. They will ask us some good numbers, no doubt about it. So we should be able to work through those particular numbers, which is kind of essential. All right, yeah, okay, that sets us for the next question. I'm hoping that, okay, it's kind of making sense to you. I'm setting up the next question here. Beautiful question. Beautiful question. You may say that, what is this? This is 39 raised to power 99 raised to power 80. Yeah, take a look at this. How do we go about this particular question? Yeah, done. All right. So nevertheless, so it's a top-down approach. Top-down approach means what? If you have a number 2 raised to power 3 raised to power 2, top-down approach, first you got to resolve these two. That is 3 square you should resolve. These two, first you will resolve top-down approach. From here, you got to resolve 3 square. So therefore, you say that this is nothing but 2 raised to power 9. Okay, then you resolve these two. 2 raised to power 9 is nothing but 512, because some people make a mistake here. When they write it something like this, they resolve the bottom two. They go from bottom. They will say 3 other 2 cube. 2 cube becomes 8. Then they will write it as 8 square. This 2 they will use it there. Then they will say that now they use the bottom 2. 8 square will now become 64. No, that's not the answer. This is the correct answer. 64 is not the answer. You need to be a little mindful that you need to be using the top-down approach. What does it mean to us? Simple. I have no idea. So here 99 raised to power 80. It's a big odd number. So I will say that this number is nothing but 39 raised to power a huge odd number, because 99 raised to power 80 means what? 99 into 99, third time 99, like this. 80th time you will write 99. Product of any number of odd numbers is odd. Therefore all I know is what? Top down. When I do 99 raised to power 80, I understand it. It's a huge odd number, massive. It's a massive odd number. Good. So I will say that okay, 39 when divided by 8, the remainder is minus 1. 39. I'm looking at the base now. I'm looking at this base. 39 when divided by 8, the remainder is nothing but minus 1. Good. 39 raised to power big odd number will be minus 1 raised to power big odd number, which is nothing but minus 1. And hence you are trying to say that when the number is divided by 8, the remainder is minus 1. If it is minus 1, what I should be doing? Add back your divisor. You will get the final answer as 7. 7 is the final answer for this particular question. Clear here? Top-down approach is clear. You should be doing it from the top-down approach. If you do bottom-up, you will get a different answer for this question. Making sense? And it is not even equal to this. Hey, 2 raised to power, for example, let me use the same question here. 2 raised to power 3 raised to power 2. Is it same as 2 raised to power 3 into 2? No, it is not same. It is not same. It is not same. You need to be very careful. These two are two different information. However, this information can be same as 2 raised to power 3 bracket raised to power 2. If I write like this, this will be equal to this. Absence of bracket, it is very different, right? We need to be mindful about that. That's precisely the reason I've taken this particular question, because here you need to work from the top-down approach, not the bottom-up approach. A lot of people get confused. Top-down, bottom-up. Hey, it's more often than not the top-down. Bottom-up approach comes in the picture only when there is a bracket. Yeah, good. All right. So that's the, yeah, correct, Ashutosh. Yeah, most of us do that. That's a common mistake that people do. So therefore, I thought that at the foundation stage, I will make this point very clear. Good. All right. That sets us for the next question. Here we go. Yeah, work on this quickly now. Work on this, guys. Simple question. Why don't you guys work on this? Yeah, all right. It is stretching us a little bit. All right, fine. So don't worry about this. Hey, what is this power? This power is kind of an odd number. To start with, you will say that, sir, it is 90 raised to power big odd number, because 95 raised to power 100 is nothing but a big odd number. Correct? All right, correct. Okay. So therefore, you will say that 90 when divided by 11, the remainder is minus 2. All right, minus 2, right? A small number. You can say that plus 2, right? Remainder is nothing but 2. When divided by this, the remainder is nothing but 2. 90 when divided by 11, the remainder is nothing but 2. Very good. So that is fine. So but then point is 90 raised to power odd. Now you say that odd. Then 2 raised to power odd. How do I know if it is 2 raised to power odd? 2 raised to power odd, maybe 2 raised to power 1. 2 raised to power odd can be 2 raised to power 3. It can be 2 raised to power 5. It can be any of this. Correct? All right. Let's pay a little more attention here. So but then all right now. So with respect to 11, what do I know? I know that when 2 raised to power 5 when divided by 11, the remainder is nothing but minus 1. 2 raised to power 5 is 32. When divided by 11, the remainder is nothing but minus 1. Can I capitalize on this information? Of course, yes. Now take a look at this power, this odd power once again. Come back to this and take a look at this odd power once again, this number. Come take a look at this. 90 raised to power 95 into 95, like this you are writing 100 times 95. So this whole information can also be written as 90 times of 5k, right? I can write it as a multiple of 5 because it's 95, 95, 95. When you're writing 95, 95, 95, what is that you are trying to say? Already you are trying to say that it is nothing but 5k, right? It is nothing but 5k multiple of 5 because I want to capitalize on this. See, always you should have some picture in your mind and then try to work around that particular picture a little bit, right? Yeah, 2 raised to power 5. Now you say that, hey, this odd number is not an ordinary odd number. It is a number all at which I can also make use of. So therefore you say that this odd number is 95 into 95 into 95, nothing but 5k. Now what kind of 5k is this? Can this number end in a 0? No, this number ends in a 5, which means 5 times of an odd number, not just 5. It's a 5 times of an odd number because this number ends in a 5 as well. This number ends in a 5 because 95, 95, when you're writing 100 times, it doesn't matter. So this particular number, the unit digit is also nothing but 5, which means what? It's a 5 times of an odd number because 5 times of an even number, the unit digit becomes 0. If the unit digit is 5 here, it is a 5 times of an odd number. Very good, fair enough. And hence I'll come back to this. I will remodel this particular question. Yeah, what was this here? So now you are trying to say that, hey, here all 2 times of an odd number is nothing but, I will write this as 2 raised to power 5 times of an odd number. I can write it like this. Why? Because wherever this odd was there, I was writing, all right, wherever this odd is coming, okay, just a second. So wherever this odd portion is coming, this odd portion is nothing but this, which in turn is nothing but this, and precisely that is what I'm shifting this odd to this particular place. Good, I shifted it here. So now you say that a 2 raised to power 11 when 2 raised to power 5 when divided by 11, the remainder is -1, which also implies 2 raised to power 5 times of the odd power. Hey, where is that odd power? Here. Odd power when divided by 11, the remainder is going to be -1 times of an odd power, which is nothing but -1. Technically, you are trying to say that the whole net remainder is -1. In the sense, 2 raised to power 5 times of an odd number when divided by 11, the final remainder is -1, which I cannot take as the answer. Therefore, what do? You go back and add the divisor. What is the divisor? 11. Add back the divisor and call the final remainder as 10 for this particular question. Pretty good and simple and elegant question. Okay, this is bringing us closer to the end of the lecture. Couple more questions. There are another 1 or 2 important points to make and which you also should kind of remember. With that, we will close, right? Once we kind of make that particular point, I will be able to close this particular lecture. Good. Yeah, that brings us for the next question. Let's go to the next one. You may have to just give me a few seconds. The screen is a little stuck. You may have to excuse me, guys. This screen is a little held up here. Let me quickly see if there is a Yeah, screen is stuck, Asutosh. There is some issue and the screen is kind of stuck. It's reopening. Yeah, here we go. All right. So let's couple more questions. Very important ones. The last few questions, pretty important ones. I want you to take a clear look at them. Go ahead, friends. Go ahead. Take a look at this. Go ahead. Take a look at these questions. Just take a quick look. We'll do it together. Okay, what is the remainder when 1000 raised to power 1000 is divided by 77? Very important question, right? In fact, it's very important question. How do I go about solving this particular question? 1000 raised to power 1000 when divided by 77, what is the remainder? That is the question. Okay, you need to understand that a 1001 is one of the beautiful numbers, right? 1001 when divided by 7, or 1001 when divided by 11, or 1001 when divided by 13, the remainder is going to be 1. All these numbers gives me a remainder of 1, because 1001 is made up of 7 into 11 into 13. All right, in fact it is made up of 7 into 11 into 13. That's very important. So therefore, if I take 7 and 11, it still becomes 77. Therefore you say that, hey, 1001 when divided by 77, the remainder is nothing. The remainder is 0. Right now all these gives the remainder 0. So all these functions, 1001 when divided by 7, 1001 when divided by 11, 1001 when divided by 13, the remainders are 0, because 1001 is nothing but this particular number. 1001 when divided by 77, remainder 0. That is the fact which you will kind of know. From here, where do I reach? Therefore you say that 1000 when divided by 77, the remainder is minus 1. Very good. So therefore 1000 raised to power 1000, right? 1000 raised to power 1000, which implies that minus 1 raised to power 1000, the remainder is nothing but 1. Remainder is 1 for this question. What is the important thing I want to tell you? This is very important. 101 is a prime number. Very important to know this. 101 is a prime number. Then 1001, right? 1001 is a product of three prime numbers, 7, 11 and 13, and it has 8 factors and all those kind of stuff, right? Factors we kind of studied there. And also 10,001 is nothing but 73 into 137. Now these are three important numbers. Along with that, you may have to remember a little bit about 999. 99 is very simple, all right, which is nothing but 9, and which is nothing but prod 9 and 11, that is nothing but 3 power 3, you can write it, 3 power 2 you can write it, and 999 is another important number. This is nothing but 27 into 37. Easy to remember, 27 into 37. These are 5 prominent numbers you may have to kind of remember. Some story behind this. These 5 prominent numbers are very, very important when we go on to the intermediate stage, and hence it's very important for you to remember these 5 prominent numbers. So out of this, this very purpose of giving this particular question is helping you to remind the importance of 1001. 1001 when divided by 7, 11 or 13, the remainder would become 0. So therefore 1000 when divided by 77, the remainder becomes 1, is an important part of this particular question. Good. So that sets it for the last question of the day. One last question there. One last question, another important point to make, and then we are kind of sorted. Go ahead, take a look at this particular question. Yeah, recalled, very important, right? This is another important stuff. 2 raised to power 10 2 raised to power 10 is nothing but 1024. That's 1 kilobyte, which is also nothing but 32 square, which is also nothing but 1 kilobyte, which is also nothing but the smallest 4-digit number, which is the perfect square. This is the smallest 4-digit number, which is a perfect square. 210 is a very powerful number. It's one of the very powerful numbers used in the remainders application. See, there are some very popular numbers. Popular numbers, at least we should know. Okay, coming back to this. 2 raised to power 99. It sets us there. 1024. That should come into your mind. So therefore, you say that when 2 raised to power 10 is divided by 25, the remainder is minus 1. Hey, why? Because it's 1024. 1024 divided by 25, then naturally the remainder is nothing but minus 1. 2 raised to power 10 when divided by 25, the remainder is nothing but minus 1. So therefore you say that okay, 2 raised to power 10 raised to power 9 when divided by 25, the remainder is nothing but minus 1 raised to power 9. So which means till where did I go? I went up to 90. You are trying to say that 2 raised to power 90 when divided by 25, the remainder is nothing but minus 1. I just simplified this part and this part I simplified. But author says that hey, not 90 man, I want 99. Good. So if you want 99, you got to multiply both sides by 2 raised to power 9. 2 raised to power 9 here and 2 raised to power 9 here. What is this particular number? 2 raised to power 10, 2 raised to power 9, etc. You would know this particular number is nothing but minus 512. Good. So technically you are trying to say that 2 raised to power 99 when divided by 25, the remainder is minus 512. Okay, reduce the multiple, divide this by 25. Divide this by 25, you will be left with minus 12, because minus 500 is divisible by 25. Minus 12 is what you are left with. But that's a fine. Is that the final answer? No. Final answer is go add back the divisor. What is the divisor? Divisor is 25. That brings us to the 13. Okay, that sets us the preferred remainder stuff. Where is the preferred remainder here? In the very first step, 2 raised to power 10. This is the importance of 2 raised to power 10 here. Okay, that brings us to the end of this particular lecture. I'm hoping that you kind of clearly understood the importance of preferred remainders today, right? The whole importance of preferred remainders, you guys have to be clear by now. I guess you are pretty kind of clear there. So yes, all right, that's pretty much about today's lecture. And how you, if you have any doubts or something, you can reach out to me by using one of these particular Telegram channels, and you can also have some healthy discussions on that and some peer learning as we go along. Yeah, and you have any short counseling needs, you can use this particular forum, so you can ask me some questions there. And meanwhile, I will also ask you a few things whenever you ask for some doubt, or so whenever you kind of ask for some sort of suggestions, etc. I always start by asking a little bit about your profiles, etc. That helps me to guide you better. So yeah, that's kind of brings us to the end of this. Okay, if you have liked this particular video, whether you are doing it online, offline, whenever you kind of do it, you can always press on it. If you like some content, you can say that like, that would be encouraging to me as well. And subscribe to this particular channel, press on the bell icon. Whenever I start the next lecture, you'll kind of get to know about it. Yeah, that's pretty much about today's lecture. Hope you enjoyed and you learned the lecture, learned something about the preferred remainders today. I will see you in my next lecture. Bye till then, stay blessed. God bless you. God bless you. God bless you.